Okay, what's up, everyone? Um, Quite exciting because today we're going to be diving into Snowflake Cortex and anomaly detection. So, yeah, let's kick off. So, I guess the first thing to understand is what is Snowflake Cortex. Now, if you at the docs, you can see they've got all these LLM functions, they've got ML functions, and they've also got Snowpark ML. Basically, what this is doing is it's bringing advanced functionality into Snowflake via their query-like interface, right? So, if you were building out your own forecasting, you might go for something like a Serema model in scikit-learn, and that would kind of look like something like this. And you'd basically have to do quite a lot of code, right? You'd have to write all this stuff and then save this model somewhere. You don't have to do any of that with Snowflake Cortex, and I'm going to show you how. So there's this very basic table we've got here, which is some store sales, and it's not only sales over time, but it also has a dimension, right? Multiple stores. So what we're going to do is we're going to create a table that is a subset of this data. So if I check the date, I can kind of see the biggest date is the 19th of November. And, you would probably, if you wanted to do like anomaly detection on Cortex every day, which is kind of what we're doing here, you'd basically want to create this monitor, I guess, at the frequency you want to do it, right? So if this date is daily, then create this monitor every day. So, kind of imagine it's the 18th of November. We're going to go ahead and create this table. Cool. And then we're going to also go ahead and create another table, which is just, the 18th and 19th of November. And we can see that now, store sales, the greatest date is the 19th. And now we're going to go ahead and call this Snowflake anomaly detection function. So this is using Cortex. It's not using an LLM. It's just using probably what is a Serema under the hood. And you can see the syntax is really, really simple. So this is the syntax. You can actually read a bit more in the docs. Big disclaimer here. But you can see that the full syntax is here. So there are a couple of other optional parameters that kind of demonstrate that you can do slightly more complicated stuff than we're doing here. So the first parameter is the input data, right? So this is essentially the data that you're training the model on. You're doing anomaly detection, right? So typically with anomaly detection, you are using time series data, right? It's like if there wasn't a time series, then you'd basically just be looking at like a normal distribution. And then what's the definition of anomaly, right? Basically anything above the sort of, whatever percentile you choose. So that doesn't really warrant something as complicated as machine learning. But here, something like an auto-regressive integrated moving average, you may be doing that. So basically you need a time column, that's date. You need a target column, right? That's the variable you're trying to measure. The label column name, it doesn't need to be included. That specifies the name of the column containing the labels for the data, right? So labels are Boolean true, false values indicating whether a given row is a known anomaly. So if we did know that things were anomalies, we could basically automatically flag them. I don't know if you can do a combination of sort of like, I don't know that 90% of these observations are anomalies, but I know one of them is. I don't know if you can do that. And then obviously you need the series call name. So here, we're not interested in aggregating all the data at daily level. I want to know for London what's anomaly? Oh no, for Cardiff, what's anomaly? And so on. So we're going to go ahead and run that. This takes a bit of time. So you'll see these Snowflake Cortex functions are, orders of magnitude more expensive than your other kind of statements. And now what we're going to do is we're going to call this model. So you'll notice that everything's basically the same. You don't need the label, but you are going to call the model on the data you want to predict, not on the data that you just used to train the model. So go ahead and run this. And again, you can see it kind of takes up a bit more time, and we get this nice output. So this is the timestamp of the data. I guess this is the y-intercept. This is the sort of forecast, so what they expect it to be. The lower bound and the upper bound, and you can see that because this is actually, pretty close to this, right? It's sort of within the 12th percentile. It's not an anomaly. However, this is pretty rogue, apparently, right? The lower bound, I guess, for the 95th percentile is 1015, and that value is 1007, which is interesting. So let's see how good that is. So if I go ahead and say my store equals London, order by date desk. Okay, right, I'm back. So yeah, I guess that is kind of anomalous, because this is clearly underneath these lot, and I guess if you rewind it back to the 11th, I mean, I personally wouldn't say that's too anomalous, but can't really comment on the accuracy of the machine learning stuff, because that's Monday. So Sunday, Saturday, Friday, Thursday, Wednesday, Tuesday, Monday. Right. I mean, yeah, the Monday value from ages ago is 1009. But presumably, right, if this was a longer series with more obvious anomaly detection, then you'd hopefully get a better result. But yeah, the jury's out in terms of how good this algorithm actually is. But yeah, that's kind of how you run this on Snowflake.